Hi everybody, my name is Aiden, and today I'm going to be going over some derivative rules in this video, namely the power and chain rules. Um, there we go. So if you've ever done any calculus, I'm sure you've been exposed to the power rule, or maybe indirectly through definition of a derivative problems. So it's pretty basic. If you have x to an exponent, like you see here, and it's just any number at all, any constant, x to an exponent, the derivative of that is you pull the exponent down, you multiply it by that, and then you subtract one from the exponent up here. So you can see here in these examples, there's a little invisible 1 here. So the little invisible 1 comes down, 1 times anything is whatever it is before, and then you subtract 1 from 1. So 3 times x to the 0 is 1, so just 3. This one, the 2 comes down, it's 16x, whatever, you subtract 1. 11 is a constant, which means the derivative is always 0. Derivative of every constant is 0. Sometimes they'll trick you up, try to use like e. If f of x equals e with no exponent, f prime of x equals 0, because e is a constant. Same with pi, same with whatever. I plugged in some numbers here, whatever. Sometimes they'll try to trick you up if you have 1 over x or 9 over x squared, something with an x on the denominator. That can be represented with a negative exponent, then you can use the power rule. Here is like a little bit of a physics problem where with velocity, acceleration, whatever, and time is the variable instead of x, but it's the exact same thing, doesn't matter. Okay, chain rule. This is very important. This is the most often forgotten rule in my experience with talking to other calculus students, and it will completely change the concept of the question. If you're an AP calculus, college calculus, whatever, you'll miss a lot of points if you don't fully grasp and remember this rule. So all it is the derivative of a function, like here, sine of 2x. You have a function of x. It is the derivative of the outside function times the derivative of the inside function, g of x here, g prime of x. So first, really basic example, sine of 2x equals the derivative of sine is cosine of 2x times the derivative of 2x is 2. So next one you can see arctan of 3x. You have to remember here the identity that derivative of arctan of x is 1 over 1 plus x squared. You plug in 3x into where x is, so instead of x squared, it's 9x squared. And then it's 1 over 1 plus 9x squared. You multiply by 3, which is the derivative inside, and you get 3 over 1 plus 9x squared. E to the x, you can see you bring down the 2 like there. These, I have a few here where there are three layers of function. Sine squared 3x. You have the 2 you bring down, so you have 2 sine 3x times derivative of sine, which is cosine 3x, so 2 sine 3x cosine 3x, times the derivative of the inside, which is 3. So 6 sine 3x cosine 3x. This one, ln of ln of ln of x, whatever. This is really interesting if you get series in terms of divergence, convergence, but of course you're not there yet. And so what you do, you take the derivative of the outside function, which was 1 over the inside, as you can see here. Next, the derivative of the next function, 1 over the inside, so 1 over ln x here. And then the derivative of the most inside function, which is 1 over x. So you get that there. And you have a few other questions here. This is the most interesting, sine of arcsine of 2x. Sine and arcsine just cancel out, which I thought this was really interesting. I didn't even pick it on purpose until I realized. Yeah, so it just comes out to 2x. Derivative of 2x is just 2. So there's not even any chain rule here, but it looks like there would be. So thank you. Join me in the next part where I go over the product and quotient.